The stream is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello, everyone, and welcome to day 24 of Advent of Code. Merry Christmas if you celebrate Christmas. Happy holidays if you celebrate other holidays. And happy Advent of Code if you celebrate nerdiness. Hello, David.
I can only echo your comments. Hello.
All right. So, we are now with days, I want to say 21, 22, 23, and 24 on our hands. And you have some good news for us. You got a star.
I got a star. Day 22.
Tell me about it.
Right. So probably best if I send you a link to the GitHub. There was an issue with the way that we were checking the. So this was the one with the 3D blocks, and they were falling down. And I will send you the solution on Skype so that you can just view the source code. But basically, you know that subset check that we were doing?
Mm-hmm.
I think what that didn't check was like a particular block may be supported by multiple different blocks. And the check that I was doing was only checking if there was a different block which contained all of the supporting things. But actually, we need to check not just this block, but any, like, the combination of all other blocks. Are they... Do you see what I mean?
Yeah, so it's not that you are going to remove a piece because another takes care of everything, but because collectively they could take care of everything.
Yeah, exactly. Yeah, you've summarized it better than I did.
I see. And what you're telling me is that you still use the subsetting approach, but somehow in another way? Or did you go for the other approach instead of looking at the things that a piece supports? You looked at what a piece is supported by.
I just more the other approach, so more the latter, which is I basically just check if this piece is only supported by one piece.
Mm-hmm.
So I go through each piece, and then I look at the pieces that it's supporting. And then I'm looking at a piece which is supported by me. And if that size is 1, then I know this piece cannot be disintegrated. Otherwise, it can be.
That's great. And did you have to do another pass? No, when placing the pieces, you already do this.
Exactly, yeah.
And then you just check. Okay, that's exactly what we had in mind when we left off, and you got the star. Good job. Congratulations.
Exactly.
So
nice and simple.
That is...
Yeah, we did the hard work. The hard work was coming up with the matrix idea.
Well, I would say that in the spirit of the season, it was very much a collaboration. So I'm very happy about that. And I want to at least take a look at part 2. So let me get the stars so they can put part 2 on the screen. And this is day 22, part 1. Okay.
I'm not sure if your input's there or not. You can collapse it using the toggle thing, by the way.
Yeah, and I will send you a... No, I will not send you a Visual Studio Code live share link because today you are driving, right?
Ah, yes.
I was
Well,
driving yesterday, if I remember right.
yeah. But also 22 is even, so I guess it's also technically one that I would drive if we were to do part 2. How about I want to show you what I've been thinking about for part 3. For day 23.
Oh no, there's part 3 now?
Sorry, no.
You're telling me that I need to use TSM to be able to run this, right? I then run this
yeah.
with node require TSM.
Yep.
Good job, David.
Beautiful.
You are a smart person. So, do you want to
thanks.
do at least read over part 2?
I definitely want to read over part 2.
Okay.
I definitely want to discuss my thinking around part 2 of day 23.
Mm-hmm.
And I would like to do part 1 of day 24. So
that's what's on the menu.
That's what's on the menu. The decision is the order that we do things in.
I want to read part 2 of day 22 because that's where we were at. So take it away, David.
Sure. Disintegrating bricks one at a time isn't going to be fast enough. While it might sound dangerous, what you really need is a chain reaction. You'll need to figure out the best brick to disintegrate. For each brick, determine how many other bricks would fall if that brick were disintegrated. Using the same example as above, disintegrating brick A would cause all 6 other bricks to fall. Disintegrating brick F would cause only 1 other brick G to fall. Disintegrating any other brick would cause no other bricks to fall, so in this example the sum of the number of other bricks that would fall as a result of disintegrating each brick is 7. For each brick, determine how many other bricks would fall if the brick were disintegrated. What is the sum of the number of the other bricks that would fall? Gotcha. Okay. That seems relatively doable. Shall I share my live share?
Oh yeah, let's do that. And or maybe not. Let's just perhaps talk about what we could do and try and go to day 23 and 24. Just spinning lots of plates here, but
okay.
What would you do?
Yeah. Well, I mean, high level, I would go through each brick to disintegrate, and then calculate the resulting number of bricks that would fall, and then add them all up. Now, how would I calculate the number of other bricks that would fall? So I have the ones which are supporting. So I would check if that is now pointing to. I would traverse the items. So for each one which gets disintegrated, if that one that it was supporting gets disintegrated also, or falls because of that, because there's nothing else supporting it, I would keep traversing it basically up the tree.
Yeah.
We're choosing the bricks which are disintegratable. Doesn't that mean the bricks which you can pull out which won't cause movement? So they changed the problem now.
Yeah, the problem is now we are going to try and disintegrate each brick one at a time, not all at once. And then when we disintegrate one of the bricks, how many others would fall? So if there is a brick that is simply supported by A, we disintegrate A, it will fall. But also, if the brick that fell is supporting another brick, and it is the only support, that will also fall. And so on and so forth. So that's why it's a chain reaction.
Yes. That makes sense.
How large is this input? Because there is a naive solution that perhaps is tractable, which is just
we do the falling algorithm that we already know how to do. Then we remove one of the lines from the inputs and just perform the whole algorithm again and check how many bricks are in a different position now because of the elimination of this brick. So there isn't a lot of new logic to think about. It's just a matter of like running the same logic over and over and doing what probably amounts to a map comparison, I guess, or a list comparison.
Yeah. Yeah. I was definitely thinking brute force, but I was thinking more of traversing things. But this is much smarter. You could just run the same algorithm again.
I'm looking at the inputs, and it may be a bit a tad on the large side, but not so much. Because the falling algorithm is a sort which we can reuse. We can use a single sort for all of the falling algorithms. So that's negligible. And then the falling itself is kind of linear. So the whole algorithm that I'm proposing is kind of n squared or n cubed. It doesn't look exponential, so it should be tractable.
Yeah, I think it doesn't seem that like you saw how fast it ran for. It should be n squared, right? Because you're just running the same algorithm
Yeah.
n times. And it ran pretty fast for n, and it's not hundreds of thousands, right? How many are there here? How many lines? It's like hundreds.
Yeah, I would say like it's about 1500.
Yeah. Yeah. So running that 1500 times should be doable.
Yeah. So
That's a nice solution. Would it work, the idea of traversing as well?
yeah, the problem with that is that A supports B and C.
So what you would do is you would just go up the tree. So you would look at the ones. So I've slightly changed the data structure. So it says like each node is supporting things and supported by things. And you go to the ones that it's supporting. You delete something, go to the ones it's supporting. And if that supported by has now dropped. Oh no, because you need to take into account which has the largest height. No, you don't. Yeah. So you traverse to the ones that it's supporting. This node is supporting, and you see, was it only supported by that individual node? If it was only supported by that node, therefore it's fallen. And then you continue the algorithm. You see what I mean?
Yeah, you have to do the whole algorithm again. You cannot simply say if B has fallen, then everything that B supported is also falling, because the things that B is supporting could also have been supported by something else that will stay in place.
No. Well, that's not quite what I was thinking. I think it does work.
Yeah, I think it does work. What I'm saying is, I think it does work. What I'm thinking is,
I don't think you have to run everything again, though.
no, I'm just saying, you cannot cut corners and simply say, oh, if B has fallen, then everything that B supports has fallen as well. What you have to do is look again. And when I say do the algorithm again, I mean, in this case, the algorithm in this sentence is the fact that you need to check what is supported by what, again, from scratch.
Yeah. So, is this day 22?
It is.
Okay, I'll create a part 2, but I won't write the code. I'll just say high level what I think you could do. So you just go for each piece. You're going to or rather, you have like this work list, right?
Mm-hmm.
Which is, let's say, like, is the like removed piece. And then for each piece, you're going to check. For each, sorry, dot supporting. You're going to check if X supported by size is 1, then like, yeah, push it onto the open list, kind of thing.
Mm-hmm.
And like plus the number of pieces which will fall.
Yeah, I can see that. Yeah. The open
Something
list.
something like that.
Yeah, the open list is like
Removed.
the pieces that I have disintegrated, and now I'm looking for the consequences of their disintegration.
Exactly. Yeah.
Yep, I can see how that can work. Yeah.
Yeah, because I think what's key for this to work is that like we're only ever dealing like one level at a time. You can never be supported by pieces on different levels. You're only supported by a piece at a particular level, so it should always work.
Oh, and there is another consequence of this. A piece falling in our very specific problem statement is equivalent to a piece being removed. Because if it is removed, then the pieces above will fall, and if it itself has fallen, the pieces above will fall, which to our problem statement is equivalent. We don't care if a piece is fallen because the one below has been eliminated or the one below falls itself. So what you could do is go from top down and then answer the question like, if I remove this piece, will the one above fall? If so, then okay, add 1 to the list of pieces that would fall, blah, blah, blah. Add 1 to the result, ultimately. And then when you go down and you realize that removing the piece below it will make this one piece that we are talking about move as well, we can add 1 again because we know that the one above it will move. I guess what I'm trying to say more simply is that if we work from the top down, we can reuse our work. We don't have to keep asking the same question over and over.
Yeah, I think definitely it seems very memorizable, right?
Yeah.
Yeah, I mean, it sounds like what you're thinking of is like pre-computing everything, like a dynamic programming approach.
I'm thinking dynamic programming from the top of the Jenga tower down, and anytime that you make a piece fall and you can realize, okay, the one above is going to fall with me, just add again the result of that piece being removed.
Yeah, I guess this would be very memorizable. So you could just do like if get the key, and then like if key in cache, then return the cache key. Otherwise, we could do like something like ret equals sum of the remove piece in supporting, something like that. If you see what I mean. And then it should be similarly like reusable work.
You may not want to do this exactly this way because you don't want to say that just because one of the pieces that support a piece has been removed that it is going to fall. We don't know. Yeah.
Something like that. There's got to be some kind of if. Yeah. Okay. So I think we're in agreement with part 2. If we have time, we can implement it today. Should we have a look at the other things?
Let's take a look at day 23.
Day 23. So day 23, I have some visualizations and some discussion. So yeah, you can play that. I'll watch you. Oh yeah, if you move the arrow outside, you can see it better. But yeah. So all this is doing BFS. But this is how our algorithm works, or at least kind of. Anyway, it's doing BFS, and the thing is that we will. Each of these like red lines, the bifurcations, they're totally separate paths. And what happened? The reason it's taking so long is, as you'll start to see, like we start to visit nodes that another path has visited. You see now they're starting to overlap these paths.
Yes.
And they're starting to go back. That's where we get like really bad compute. We shouldn't need to do that. So I think your idea of like doing one pass in the beginning and finding all the segments and then creating a new graph with weights between those different like junction nodes would make a lot of sense. And then you could find the longest path with that new graph computed. But I'm wondering if there could be an even smarter way where you just do like one pass all together, and you basically you never go back to where you've come from. You never go. As soon as you see a node that you've already seen, you just mark that as like, and you've come from a particular node. Like I have an idea of how to compute this, but it's not very clear in my mind. If I can take you to Excalibur, I can tell you more or less how I'm thinking of implementing this, but probably you'll have a much better, a much cleaner idea, because I feel like it's close, but it's not quite there. I'll just quickly send it to you. So, so yeah, I'm over here. So the idea is, you can ignore that one. So the idea is sort of a breadth first search, explore all the paths, but keep a global scene so that we never revisit a node on another path. So if one path has explored that node, then we don't revisit it. The only thing we do is we keep track of. So if this one is A, this one is B, and this one is C. What we do is we keep track of the distance from A to B, and then we keep track of the distance from A to C. And then what happens is B will continue doing something else, but let's say C gets to B here, and when it does, we say, okay, we found a new link from A to B, which is longer than this link.
Mm-hmm.
And so therefore we update that distance to be the longer distance, and then we stop traversing there, kind of thing. We don't go back this direction down a path that we've already visited.
Mm-hmm.
That's my general idea.
I understand the idea. I think it's great. And I love that you visualize this so that we can really see what the problem is in terms of performance.
Mm-hmm.
I will add that I didn't actually intend on this, but kind of by accident, I did leave the code running overnight, and it is still finding paths. It's giving us like not necessarily great answers, but it's still running and it's still finding paths. Well, and it's kind of finding paths fast enough now. As I speak, it's finding paths. And that was not the case yesterday. It found one path and then it took a long time to find another one. But yeah, just thought it was interesting that it keeps going. And I think I know how to implement this idea that you are explaining. And it reminds me of something that I saw in university 10 years ago. But it's kind of similar to the implementation of the, I think it was day 21? That. Remember how I implemented this thing by saying like...
Oh yeah, this one is super confusing for me to get. But yeah.
But the crux of the implementation is the solution for 64 steps starting here is the same as the solution for 63 steps starting there, union the solution for 63 steps starting there. And the solution for 63 steps starting here is the same as the solution for 62 steps starting there, union 62 steps starting there, and so on and so forth. So I use the call stack as the mechanism for combining the solutions together. So what I'm saying is, coming back to your drawing, you could go like this. The solution for what is the largest path to, we are talking about day 23 now. Yes. You could think about it this way. The solution for how many steps does it take, the largest path between this and that, is equal to 1 plus the solution for this dot. Oh, and what is the solution for this dot? Oh, it's 1 plus the solution for this dot. Oh, and what is the solution for this dot? It's 1 plus the solution for this dot. Blah, 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 until you get to a bifurcation. And what is the solution for this block? It is 1 plus the solution for this block. Oh, and what is the solution for this block? It's 1 plus the solution for this block, or 1 plus the solution for this block, whatever is largest. So in essence, what I'm saying is 1 plus the max between the solution for this and the solution for that. Now, if you carry through this, when you find a junction point, for instance here, you will find it twice. You will first find it from this and then find it from that direction. But in both cases, you will ask the same question. It's 1 plus the solution for this block, and it's 1 plus the solution for this block. But the solution for this block is the same for both, so you can memorize. And then you are guaranteed to not rework from this point on out.
Yeah.
Which linearizes the problem. It was exponential, I think. Every bifurcation you had to do like twice as many computations. And I think with this junction thing, it will maybe turn it into a polynomial, but don't quote me on this. So I think that implementation-wise, we could go about it this way.
Yeah, definitely. So I think just a recursive solution maybe then, with a cache key. It's very similar to what we just wrote, kind of thing. Could work really nicely. I agree. It's that deduplication where it's like, how do we? That's very nice. Yeah, and I actually think that depth first search might be fine for this as well. Like we're doing it breadth first search, but it doesn't matter, right?
Yeah, and that's another thing. Yeah, I agree. Depth first search could work equally well. And I was doing some reading this morning about a very interesting remark you made yesterday about how when we are finding the shortest path, we can save ourselves some work because we find the shortest path by using A star, and we don't have to keep finding other paths to prove that we have found the shortest.
Using BFS.
Yeah.
But yeah.
And when you're finding the largest path, it's hard to tell because you have to find all of them to make sure that you have found the largest. And this kept bugging me because it seems like there is an asymmetry between shortest and largest, and I thought that was strange. So I did some research on this. And guess what? On the general case, you are right. It is the fact that finding the shortest path in a weighted graph for a generalized graph is, if I remember correctly, like a polynomial for the shortest path and exponential, not even exponential, NP hard, like for the longest path. And I thought that was very interesting. Now, as it turns out...
Really? Wait, hold on. No. It should be linear for the shortest path.
Okay, that's polynomial. Linear is a polynomial with exponent 1.
Okay, fine.
It's just that I didn't know it was linear, so I was just generalizing. But yeah. The problem of the longest path on a general graph is NP complete. Which is kind of interesting, right? And as it turns out, this is not a general graph. This is a directly cyclic graph because we don't want to revisit places we have been. So for that problem, the solution is still linear for the longest path. And I think that what I just explained about the 1 plus the solution for the next dot is how you make this linear.
Yeah, that's very nice. That's very nice. I think that would work a lot.
Because if you think
I
about
think
it,
that's
doing it
pretty-
that way,
pretty-
you will not revisit the same dot multiple times. So you will only visit every dot once, which is linear.
Yeah, 100%. I like that as a deduplication method. My thinking in Excalibur, I wrote some pseudocode, but I really don't like the way it was working. So I was gonna go like, for each node that I'm looking at, I'm gonna look at all the directions. I'm gonna keep track of the previous node so I don't go back the way I was coming. And then, but if it's a node that I've already seen, like in the global scene variable, then I'll track that distance based on whether it's bigger or smaller, like the max distance. Otherwise, I'll keep traversing, basically. But I like your solution much better. It's much cleaner and easier to understand, and I'm not even sure, like, these implementation details seem pretty hazy to me.
Okay.
So, but yeah, so okay, cool. So we have an idea for day 23.
Yeah.
So should we do day 24?
Yeah. I love the visualization. It really helps unlock everything for us.
Yeah.
Good
that's cool.
job. Good job. And this is this one of our inputs, or did you draw this by hand?
This is the test.
Okay.
Yeah, this is code. Like it does. I could do it with any input.
Yeah, and you did this in the browser?
Yeah.
All right.
Yeah. It's I don't know if I pushed it up. Well, if you're in VS Code, I can show you the code. What's this? Day 22. Is it day 22? Day 23. So yeah, index.html is just this. It just imports this TypeScript file. It's using parcel.js, and then I just have this visualized path, which I call basically each time I visit a node. Just call visualize path and then sleep for 200 milliseconds so that it's visible. And I just replace this HTML element
Okay.
every time. Redraw the whole thing. It's just a div containing rows, which I just build each time, and then I just change the color based on the
You're
rows.
using your favorite color. Awesome.
Yeah, exactly. So yeah.
All right. Fun stuff. I love it. So
Very cool.
let's take a look at day 24.
All right, I'm excited. I shall read it. Never tell me the odds. It seems like something is going wrong with the snow-making process. Instead of forming snow, the water that's been absorbed into the air seems to be forming hail. Maybe there's something you can do to break up the hailstones.
This is hail. A large
Yeah,
hailstone.
as somebody who's lived in England before, I'm very familiar. What's the name in Portuguese, actually? I forgot.
Granizo.
Granizo, yeah. Okay. Maybe there's something you can do to break up the hailstones. Due to strong, probably magical winds, the hailstones are flying through the air in perfectly linear trajectories. You make a note of each hailstone's position and velocity, your puzzle input. For example, this. Okay. Each line of text corresponds to the position and velocity of a single hailstone. The position indicates where the hailstones are right now at time t0. The velocities are constant and indicate exactly how far each hailstone will move in 1 nanosecond. The position, what's constant? The velocities are constant and indicate, okay. It says no acceleration, I guess. And so each line of text uses px, py, pz, vx, vi, vz. For instance, the hailstone specified at 2019 has an initial position of 2019-15, a velocity of 1, -5, and -3. Okay. After 1 nanosecond, it will be 21, because moving 1 in that direction, then 14, yeah, okay, 12, okay, makes sense. Perhaps you won't have to do anything. How likely are the hailstones to collide with each other and smash into tiny ice crucibles? To estimate this, consider only the x and y axes, ignore the z-axis, looking forward in time. How many of the hailstone paths will intersect within a test area? The hailstones themselves don't have to collide, just test for intersections between the paths they will trace. In this example, look for intersections that happen with an x and y position at least 7 and at most 27. In your actual data, you will need to check a much larger test area comparing all pairs of hailstones, future procedures, the following results. So is it asking us how many will go through a certain x and y like square, or how many will collide?
I suppose they each of the hailstones are one dot in one direction. So they are describing a line on the Cartesian plane.
Yeah.
And what they're asking is for hailstones A and B, if you draw the lines on the Cartesian plane,
Yeah.
you don't really care
Do they?
about the hailstones themselves, just the lines that they describe. Will they intersect
This
in
square.
this
Yeah.
square described by x and y between 7 and 27?
Yes. Wait, hold on. They've just given us with an x, y position at least 7 and at most 27. Oh, so it's 7, 7, 27, 27?
Yes. So it's
Okay.
describing a square in the Cartesian plane, and
Yeah.
they're asking, are the lines going to intersect inside
Okay.
this square?
Cool. All right, and then let's go down. I'm not going to bother reading the examples yet. So in this example, there are 2 hailstones. See if any hailstones might. Look for intersection that happen with an XY position, at least this and at most that. Disregard the Z-axis entirely. Okay, I guess the part 2 is going to be the Z-axis, but we'll find out. How many of these intersections?
Okay, yeah, continue, yeah.
How many of these intersections occur within the test area? All right.
Well, hang on, I don't think I understood this paragraph. You need to see a much larger test area if you want to see if any hailstone might collide. Look for intersections that might happen within an XY position of at least blah and at most blah. Disregard the X. Okay, so in the real input, we will have more hailstones, but not only that, we will want to have not looking from 7 to 27, but from this large number to that large number. So it's a square in the Cartesian plane, but it's a much larger one.
Yeah. So I guess there's 2 ways of doing this. The dumb way and the smart way. The dumb way is to, really do all the velocities. Like really simulate the path of every hailstone. The other is just to use some maths to intersect a quadrant with a line and see if they intersect.
I would use the mathematics to see if 2 lines intersect or where 2 lines intersect, and then see if the intersection lies within the square.
Yeah.
Okay.
Yeah, that works. Well, yeah. So, okay, let's go to VS Code so that we can discuss there.
And do you know how to, given 2 lines, tell if
No.
they intersect or tell where they intersect?
I will have to Google that.
Yeah, I don't know either, but I think it's fair game for us to Google that, right? It's not cheating.
No, yeah, that's fine, I think. I'm going to go with TypeScript because it is fun to do visualizations. If we need it, it's always there. I actually wrote it in Python earlier, and then I wanted to do the visualization, and I asked ChatGPT to convert it into TypeScript. That was fun.
And how successful was it?
Apart from trying to use in with a set, it did everything perfectly.
Awesome.
Okay, let me grab this.
Yeah. Okay.
That's kind of annoying. That like the input is. We also have another bit of data with the input, which is the region. I guess what I'll do is I'll add the coordinates to the last line, maybe.
As you
So that
wish.
we can, just so that we can easily comment them out. You see what I mean? To why is this failing? Oh, okay. Oh, did I? Sorry, I probably screwed that up. My bad. Let me share that again. Sorry about
What
that.
happened?
I just reloaded the window because there was like some TypeScript error.
Ah.
I think I haven't configured the project correctly, so it's like if you redeclare things in two files, it starts to freak out.
That's funny. Worry not. I will be back in a second. Continue typing.
I just wanted to agree on the high-level pseudocode, which would be like, for each line, check if it intersects, or check where it intersects with the line 7. Something like that.
That's not how I see it. I think it is for each pair of lines. So we're going to take line 1 and 2, then 1 and 3, then 1 and 4, then 1 and 5, and then 2 and 3, then 2 and 3 and 4, and so on. For each pair of lines, we will see where do these lines intersect.
Hold on, we don't need to do that, do we?
And then I would ask, is the intersection between the square x equals 7, x equals 27, y equals 7, y equals 27? That's what I understand the problem is asking for.
I thought it was just if it... Oh, I see. Ah, sorry, yeah, then now I understand the problem. Okay, yeah, you understood it correctly. Yeah. For each pair of lines, check where they intersect. Is that point inside the rectangle? So we can do that. Actually, is that is it like this?
Yeah, I know what you're thinking about. It's an iterator, and there is an asterisk somewhere in the syntax. I think it is that.
Okay, cool. And then, so we've got a pairwise iterator, and then we're going to need lines intersect at. And then, is that what we need? Excuse me, 1 second. Sorry about that. My niece came to visit.
Ah! Hello!
Okay, where was I?
You were defining this line intersect at, and I have no idea what this is about. I know what is a determinant. I know what this looks like, but I don't know why this is correct. Now, I believe it is correct. I just don't understand it.
So we need for a line, we just need the x and y, right? And c.
And what is C?
The y intersect. Oh no, m and c. So this is like y equals mx plus c.
Ah,
That's a line, right?
well, yeah, okay. We have different ways of representing this, but yeah.
And so I was thinking to just let Copilot work out line A. Perhaps that's right.
Perhaps it is.
What do you think? Should we do you have the should we have a look at what it's doing first?
Yeah, let's do two
So
lines that we know where they intersection. And but before we continue with this, are you sure that this representation is the best given the inputs of the problem? Because we have a dot and a direction, and then we would need to do some work to turn this into this representation, right?
Yeah. Definitely would. Can you think of another representation?
Well,
So like what we have now is like is something which looks like a traveling dot, let's say, which has got, yeah, something like that.
yeah. Now that would be awfully convenient if we had an equation to find intersection given a representation in these terms. Okay, I can see how it's doing it.
That's interesting. So this is line A. So it's doing 3 different lines.
Yeah, what is the third line about?
Well, the third line is because it's considering Z, because that's how I've done it.
Ah, okay.
But that might be, if we just change this to not have Z, and then get rid of this one, then we can do that. Maybe.
It's a bit odd to me that it's not using y here to determine line A. I suppose the line A line A was supposed to be a line, and it's not even considering anything about the y-axis, and it's mixing up the dots. These equations don't look right to me.
Yeah, I agree. We'll give Copilot one more go.
Okay, at least now it's only using dot A to determine line A and dot B to determine line B. And it's doing whatever it's doing to determine M and C. And I can see why this may work. I mean, M is what we call the slope of this line. And it makes sense that the slope of the line would be the ratio between the velocity on the y-axis and the velocity on the x-axis. And it appears again here, and it's being multiplied by some coordinate and subtracted by, it kind of may make sense, I don't know.
So I guess we have two choices. Should we try and work this out from first principles? Should we Google it, or should we just check if this works?
Let's check if this works.
Okay, so let's do the example that they gave, which was 19. I can just take it from here. So it's going to look something like dot A is this. So const dot. Did it do that right? 1913. Vx is -2 and 1. Yeah, okay. And then dot B. And then am I cheating?
What result did you get?
I don't know. I haven't run it just yet.
It's a fine line, David.
It's definitely a fine line.
You are getting the right answer.
Okay. I mean, I haven't done much thinking yet. I guess, yeah. I guess I am cheating. Okay.
Carry on.
Okay.
It's Christmas. We are getting a gift.
All right. So if I do, what's this? I guess lines, string, and then target, quadrant, string. And then I don't love that the way of doing that, but yeah, no, I don't like that. Is it split by an app? Yeah, it is. And then
Hello, Bo and Nick.
target quadrant string, and then if x is greater than this is not actually low, this is just low and high. Target low and target. Is it inclusive?
I'm gonna bet that yes, but I will seek an example to give a definitive answer while you are working this out.
Greater than or equal, greater than or equal. Oh.
Ah. I'm gonna say inclusive, David, but there is more work that we need to do.
Okay.
There are two more things that we need to consider. Are you ready? Or are you thinking about something else?
Well, I think I want to verify this is correct, but what else are we missing?
We are missing two things. The first is kind of obvious. The hailstones may be in parallel. They may have parallel roots. They will not intersect. So in our little intersection function, I bet that we'll be dividing by 0. Because the amps will be equal.
Okay.
So that's easy enough. That's an if. But the other problem is perhaps a bit more interesting to think about. And that is, we are not just looking at the line intersection. We are looking at the fact that the hailstones start in a certain position and they go in a certain direction. So if let's say that the hailstones start here and they go in these directions, okay? So the lines that they trace will intersect, but they will intersect in the past, and that doesn't count. Not even if the past is inside the area of interest.
Yeah. So we need to work out, is it in the right thing? So
and I suppose that this is easy enough. Think about it this way. Here is our region of interest, and here is our hailstone, and here is our direction. If we are to the left or below our region of interest and our velocity is positive, it means that we are going to cross it at some point. So if there is an intersection that is in the square, we can do this other check that I just mentioned. Like, are we to the left and below, and is the velocity positive? Or equivalently, are we to the top and to the right, and is our velocity negative? Otherwise, the intersection must have occurred outside, must have occurred like in the past, so to speak.
Yeah.
I think that does it. So we need two ifs.
Yes. Okay. I'm just wondering where to put those ifs, but
I'll take over and I'll put this if here. If the line AM is equal to the line BM, then return undefined, because you are asking the question of the intersection that is undefined. No analysis paralysis. Move on.
Yes, that's correct. Yeah, this just needs to. And then I think we can return early here as well.
How so?
Well, if the line has already passed the intersection location, the target, then if it's traveling away from the target, then there is no intersection possible, right?
So you want to check first the direction and then the intersection. Okay.
Yeah.
I got a kalimba as a gift.
A what?
A kalimba.
What's that?
This is a kalimba.
Ah, very nice. Let's hear it. Very nice. I enjoyed that. Very cool. I've been playing my niece's xylophone quite a lot. Trying to get a few tunes by ear, but struggling.
Yeah, we had a baby over and I was playing his shaker and singing samba, introducing him to samba.
Very nice. Okay, so if direction is traveling away from the... So I guess I'm going to need the... Maybe I can do it...
Even before calling dots intersect that. Oh,
yeah.
We're at that point in the relationship when we can complete each other's sentences. How cute.
So... Do I need to know, does it need to be traveling in both the directions? So my thinking is, I'll find out, is the target low and target, are they both positive? Are they both greater? The target X and target X low and target high X, are they both greater? If the velocity is greater, then okay. Otherwise, they must be negative. I basically do the signs match, is what I'm thinking.
I think that
Is that good enough?
I think that there may be a simpler solution here. We could just look at dot a x is less than our target high and dot a vx is positive. I guess you will invert the conditions so that we can say like if continue. And
Yeah.
or the same for B.
Oh yeah, you don't need to check both target low and target high, right?
Because that's what the intersection is going to do for us.
However, what if you're inside the high? So here you're checking that if you're above the high, don't you want to check the low?
Yes. When I inverted the logic, I didn't invert this part.
That's kind of hard for me to think about.
So
whether these are right or not.
So
if it's above the low section,
let's Xcode draw real quick.
Yeah.
In the shared doc that we already have. So here is our area of interest, and my claim is that there could be a problem in which two lines intersect in the box. Well, that's not great, is it? They intersect in the box, however, that intersection should not count, because actually the hailstones are in the red dots. And not only that, they have been defined in such a way that they are pointing away from the area of interest. So an intersection does occur, but it occurs inside the box, but it occurs in the past. So the problem here is that our X is above the end and pointing right and positive.
But it could also be here.
Yeah, there.
So I think we could just check whether if it's
Wait a second.
If it's greater than,
Wait a second.
Can we just compare
David,
it to the low?
David, it's much simpler. It's much simpler. Don't worry about the box. Don't worry about the box. We have this point here. We have this x coordinate. We have that x coordinate. If this x coordinate is greater than that and the thing is positive, simple as that. Project the problem into a one-dimensional problem. It is very straightforward, really. So maybe instead of thinking of target low, target high, just compute the intersection. And then look at the intersection and look at one of the points and do this simple logic of like, is the point greater than the intersection and pointing right? Or is the point less than the intersection and pointing left? Simple as that.
That makes sense. Let's do that.
Yeah.
I'm just going to... add the x and y, and then this will return a point or undefined, and this will return a point or undefined, and this will do that. I don't know why it's thinking about nulls. And then so if intersection dot x
No.
is less,
Check first for null.
Oh, yeah.
Undefined, I guess.
yeah, if intersection dot x is less than dot a dot x and dot a dot vx is greater than 0, continue. Greater than or equal to, I guess. And then if it's greater than, yeah, that makes sense.
What's happening? Okay, you're doing both sides. You don't need to do that to y.
Oh, that's fair.
But you do need to do that to dot b.
Yeah. All right. And then
Yeah.
okay, and now we only got 2, so that's looking good. Is that our answer?
Might as well be.
Might as well be. So it does say 2. What are the intersection points that it claims?
Well, they should be
14.33.
14.33 and 15.33 and 11.667 and 16.667.
Okay, sounds good. Let's paste the real input.
Can I paste mine? Can I paste mine?
Yeah, of course. I'll let you do yours.
Thank you.
There you go. Did you paste?
Not yet.
Yeah, you need to. Well remembered.
No.
Okay. I'm still running the example input. Okay.
And can you print a sum in the end? Because this thing is gonna produce a lot of output. Enough to my terminal.
Okay, I'm going to kill this terminal, kill that terminal. Oh no, I killed my terminal. Ah. I was running the, the really long one. Oh well. Probably would have never got there anyway. We're going to implement a much nicer approach.
Hooray!
Hey!
Good job, David!
That was cool.
You are the MVP.
I am the real deal with Copilot. Oh yeah. Definitely got a helping hand there. That was useful. Would you say you fully understand the solution?
I fully understand pairwise.
Yeah.
I have an intuition, like I said, for the translation from point and direction into, is it slope and abscissa? Something like that. High school mathematics is failing me, but it's something like that.
Yeah.
Yeah, I can sort of see how you would get your y position and kind of translate it to your slope times the x coordinate in which you were looking at that y. and then you get your C. I can sort of see this. The line intersection is a bit hazier.
Mm-hmm.
Yeah.
I know. I have an idea.
Teach me.
When in doubt. GitHub Copilot, explain this.
Is that a thing?
Yeah, it is. It's writing out some explanation, but I don't think it's that.
Okay. I love this line. I mean, I wrote this line, so I know what it means, but I love that Copilot picked it up. Ah, I love this sentence. Ah, I think I understand this. Let's see. I'm doing this in a new buffer. I guess I should just do it in the same buffer. Can I start typing? David? Hello?
Sorry, my bad. I was on mute. I don't know why.
Okay. So what they're saying is that take an equation that represents a line. Like, for instance, y is equal to mx plus c. Well, now let's take two of these equations. So we will index all our variables. Why am I doing this step by step? I don't know. Oops. And why am I doing it wrong? I don't know. It's just one of those things. Now, what we are asking is, where do these lines intersect? When these lines intersect, the y-coordinates of both lines will be the same, right? So really what we are asking is, when is this equal to that?
Yep, 100%.
And we want one x-coordinate that will solve for both. So what is the x that will make these things equal? So now let's solve for x. Well, I see an x here and there. So I will pass this subtracting, and the c I will pass subtracting. And then I can factor x out. And then of course, this is multiplication, so I'll pass this as division to the other side. And just like that, look at this and look at that.
Wow.
Good job, Copilot.
Yeah, that was very good, wasn't it?
And then given that I have this x, then
It's
I
trivial.
can put it back here. So it turns into
Beautiful.
well, I have this x here, so it just turns into that. Thanks, Copilot.
That was really cool. Right, I've got to shoot off, but that was loads of fun. Do you want to read part 2 very quickly before I go?
Uh-huh, I do.
Okay, let's do it. You know what? I might leave that as a dot comment because it's always fun.
And can you also ask Copilot to explain these lines? Because it seems to be good at it.
Which lines?
The ones I have selected, the ones that convert from the dot and direction representation into M and C representation.
Sure. It's saying some stuff. Didn't mean to do that.
Okay, so it's just a ratio. This is based on the concept that the slope is a line is the change in y per unit of change in x. I can get behind this. In this case, the velocities are used as the changes in x and y. The y-intercept c of the line is calculated using the formula blah. This formula is derived from the line equation blah, rearranged to solve for c. So it's just doing y divided by mx. It essentially calculates the y value when x is 0, which is the definition of the y-intercept.
Ah. That makes sense. So yeah, wait, isn't it when x is 0?
Yeah, when
when
x
x
is 0,
m goes away, so y equals c. So no, yeah.
yeah, okay, y equals c, but where is this coming from? Meh. Let's read part 2.
Yeah, because I guess you need to, like, you're getting the y at some position on the line, aren't you? So you need to first extrapolate what it. Yeah. Anyway.
Part 2.
You need to get the m. Yeah. Anyway, so I don't know. It doesn't seem like any hailstones will naturally collide. It's up to you to fix that. You find a rock on the ground nearby. While it seems extremely unlikely, if you throw it just right, you should be able to hit every hailstone in a single throw. You can use the probably magical winds to reach any integer position you like and to propel the rock at any integer velocity, now including the z-axis in your calculations. If you throw the rock at any time at time 0, where do you need to be so that the rock perfectly collides with every hailstone? Due to probably magical inertia, the rock won't slow down or change direction when it collides with a hailstone. In the above example, you can achieve this by moving to position 24, 13, 10 and throwing the rock at a velocity -312. If you do this, you will hit every hailstone as follows. I don't fully understand, but I guess first of all we have to go into 3-dimensional space.
Yeah.
And secondly, we have to create a line which intersects all the other lines. Somehow.
No, I think that what's happening is there is a lot of lines that are going to intersect, and we need to be in one point in one of them, and then throw a rock, and then the magical winds are gonna move the rock along that axis, and when it hits a rock and there is an intersection, it's gonna start following the other wind. Maybe.
Okay. Above each hailstone is identified by its initial position, its velocity, then the time position, blah blah blah. After 1 nanosecond, the rock has exactly the same position as one of the hailstones, obliterating it into ice dust. Another hailstone is smashed to the 2 bits 2 nanoseconds after that, and so on. So at time 0, the rock, after 1 nanosecond, as one of the hailstones, obliterating it. Okay, and another hailstone is smashed to bits. After a total of 6 nanoseconds, all of the hailstones have been destroyed. At time 0, the rock needs to be at X position 24, Y position 13, 7, 10. Adding these 3 coordinates produces 47. Don't add any coordinates from the rock's velocity. Determine the exact position and velocity the rock needs to have at time 0 so that it perfectly collides with every hailstone. I think I got it right the first time. I think the magical wins is that it just doesn't lose any velocity or acceleration, or it just keeps going. It's magical because it's like a ghost. It goes through the hailstones as it destroys them without impacting the speed of the rock.
But what is the point then? Or put it another way, if we start in a place and we throw a rock and it's going to hit every hailstone, it means that all the hailstones' positions are collinear, which is not the case.
No, because you can hit them at different times. They just need to be traveling in the same direction, same like general direction. At some point, you will hit them all.
Oh. No, yeah. You need to find.
Like if we go to Excalibur,
It's not that all the rocks are collinear. It's that as you move through time, you will hit them along the way. Wow, this is crazy. Okay, I get it. It's complicated, but I get it.
so you have like if we're in go to
Oh,
Excalibur.
yeah. Over there.
Actually, we could even do change this into arrows. So you have some lines which represent the stones, the stone, right? And I guess we just want to draw a line which is like perfectly does that. Is that right?
Well, for sure, we want a line that will intersect every other line. So that's a good start. But not only that, it must be the case that when we throw the rock, so the rock is going, and all the rocks are also moving. And we need to make sure that when this line intersects this one, the hailstone is exactly here so that the rock will hit it. And then we keep going. And then when we intersect this line, well, the hailstone better be here. And then the rock gets it. And then this one needs to be there. And then it hits it. So there needs to be like a beautiful alignment of the planets here. But what the problem statement is...
Yeah, there's time.
Yeah, the problem statement is giving us a piece of information that is cool. In the three-dimensional space, the intersection points of this line and all the other lines is going to be such that the rocks are going the rock is going to get the hailstones, because I think that there is only one line that will intersect all of them. No, maybe not.
Is it true that... I was going to say, is it true that if we solve it for 2 lines, then we've solved it for all of them? But that's probably not true. And I guess it is very time dependent.
Yeah, because if you solve for 2, you may solve for 2 by going way back here or even in the future here.
I wonder if we could use heuristics to like narrow the search space rather than calculating this deterministically. We could do a kind of binary search, like just try out some lines, see how many like work out, and then like until we
converge.
Yeah. Because there's only going to be one place.
Do you think that they gave us that input in the beginning, or that square, that the square of interest in part 1 is kind of a hint that all the intersections are going to occur in that area, and therefore we could just search in this area using binary search?
That's a good point. I mean, I'm not sure if... I wonder if we got any lines which weren't going in the right direction. Be interesting to log out if that happened, because that might impact things. I'm not sure, Leandro, but I have to go.
All right. It was nice talking to you. I'll see you again tomorrow. Merry Christmas.
It was a pleasure. Merry Christmas indeed. Joyeux Noël, as they say.
Yeah, just fat.
Okay. All right. See you.
Bye.
Ciao, ciao. Bye.
Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all will be back together for some more coding or talking or chilling. The next time I'll be streaming.